Hey, I thought we would do one of these problems. So we're going to start out with electromagnetic radiation that is 555 nanometers. That's probably in the visual light range, so it's just colored light we could see. It's what makes our shirts blue and purple and green and, colors that we can see. It's kind of medium, doesn't really, it's not going to be the kind of radiation that is of a huge danger, but it's also, got more energy than radio waves, and it's got more energy than microwaves and infrared. So you got that. But so if I want to do a full run up on this, I've got a wavelength. The next thing I'm going to do is find the frequency. Okay. Now the formula that deals with wavelength and frequency is C equals lambda nu. That is the speed of any electromagnetic radiation in a vacuum. And that's always going to be 3.00 times 10 to the 8th meters per second. So the first thing I'm going to do is I'm going to take my 555 nanometers and I'm going to change it into meters. And you just got to remember this. The only time you're going to see this is with nanometers. And so 1 nanometer is 1 times 10 to the negative ninth meters. I always remember nanometers, negative nanometers, okay? So I multiply 555 nanometers times 1 times 10 to the negative ninth meters, 5.55 times 10 to the negative 7th meters. Okay, so then now I've got a wavelength that I can use. There's my wavelength that I can use because it's in meters, and then my speed of electromagnetic radiation, speed of light, is in meters as well. So next thing I'm going to do is just rearrange that equation, and I'm going to have C divided by the wavelength gives me the frequency. So I put both things I know on the same side. That's what I'm looking for. Seems pretty easy. 3.00 times 10 to the 8th meters per second over 5.55 times 10 to the negative 7th meters equals the frequency. That should be a large number. Where's the calculator? It's right here under all my junk. So 3 times 10 caret 8, boom, divided by, now you got to put parens around this, 5.55 times 10 caret negative 7 paren, boom. And yeah, I get 5.41 times 10 to the 14th. And that's a pretty good number for a frequency. And that's going to be hertz or per seconds. So you see your hertz right there. Now, I can take that frequency now that I've found it, and I can plug it into the energy equation. And you just plug that in directly. You got to remember the Planck's constant is 6.626 times 10 to the negative 34th joule seconds. And since a hertz is a per second, you got that hooked up. The second and the per second cross off. And so I'm going to take that. I can't get the cap on my marker. I'm sure you care about that. 5.41 times 10 caret 14 times 6.626 times 10 caret negative 34. Boom, boom. And yeah, and I get 3.58 times 10 to the negative 19th joules. Not too bad. So that's sort of the front way to go about the problem. And then I guess kind of the reverse way is if you have an energy, I don't know, let's say 2.68 times 10 to the negative 19th joules. This is kind of the other way you get, and that's going to be E. And so what you would do there is you would take E equals H nu, you would divide both sides by H, and you would get E over H equals nu, like that. 2.68 times 10 to the negative 19th joules divided by 6.626 times 10 to the negative 34 joules seconds. And it's really cool when you divide those out, you get the per seconds that you need. I'm going to get my calculator out here. 2.68 times 10 caret negative 19, boom, divided by parentheses 6.66 times 10, negative 34, boom, 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 and I get 4.04 times 10 to the 14th hertz, and that is my nu. So you can see that there. See how we did that. And then I can just plug that in if C equals lambda nu. And so now I'm looking for that wavelength. I started with the wavelength in the first problem. So C over nu gives me wavelength 3.00 times 10 to the 8th meters per second, divided by 4.04 times 10 to the 14th hertz equals my wavelength. C equals lambda nu. C over nu gives me lambda. Plug in this. C as well as 3.00 times 10 to the 8th meters per second. And then divided by the frequency, make sure that frequency is in parentheses. I just did that. And so 3 times 10 divided by parentheses 4.04 times 10 caret 14, 7.43 times 10 to the negative 7th meters. And if you want to put it in nanometers, make it look cool, it'd be 743 nanometers.